Alright, good day. Now here we're looking at the third variation of diagram sums, and there's still a fourth variation, writing in terms of a variable. Very common exam question, either in prelim or final exams. We will test, can you write in terms of a variable? So follow very carefully. Right, now there's many shortcuts to doing this, but yeah, I'll do it the full way as a diagram sum. Cos 35 equal P, determine the following in terms of P. So meaning each one of these sums written here must have some form of P in it. So I have cos 70, sin 35, sin 70, cos 145, minus 325, 10, 215. Because there's 35 degrees given, all of this will have to be reduced somehow, some way to include a 35. Now first, when I say cos 35 equal to P, we assume you know that it's P over 1. Anything divided by 1 stays the same. So x is given as P, but with cos x over r, r is 1. So therefore we are required now to find the value of y. So I'm going to draw a diagram. If I draw the diagram, I draw it in first quadrant, 90 degrees, my 35 always closest to the point of origin, and x was P and r was 1, so we have to find y. So y squared equal r squared minus x squared, r being 1 squared minus the x, which is P squared. Square root of y squared will then give me square root 1 minus P squared. So whenever we give you P, that one would always be square root 1 minus P. Second variation, I give you that as square root P, and this then reads 1 minus P. Right? But yeah, as you practice, you'll pick up the variation. So knowing this, we are able now to solve the problems. So given cos 35P, we know now that x is P, y is square root 1 minus P squared, and r is 1. So cos 70, to make it 35, we assume you know 2 times 35 is 70. So I've made it a double angle now. I can expand. Yeah, I use 2 cos squared 35 degrees minus 1. Now cos 35 is P. So therefore that becomes P squared. 2 stays there, so 2P squared minus 1, and I've solved cos 70. Sin 35, we assume you remember, is y over r. If sin 35 is y over r, my y, square root 1 minus P squared over my r, which is 1. Anything divided by 1 stays the same. Right, let's look at problem number 3 and 4. Right, so for problem number 3, we have sin 70. Because we're working with 35, I have to make it 35. So again, I assume you know 2 times 35 is 70. So now I have a double angle. Sine double angle becomes 2 sine 35 cos 35. Sine 35 would be my y value being square root 1 minus P squared, r1. So that divided by 1 stays the same. Cos 35 was given as P. So 2 times P, I just move the P to the front. So hope you follow. Cos 145, I have to reduce that in such a way that it has a 35 degrees. Because the only way I can write in terms of P, I must introduce a 35 degrees. So 180 minus 35 gives me 145. 180 minus 35, second quadrant, and in the second quadrant only sine is positive. Therefore cos becomes negative cos 35 degrees. Cos 35 is P, so that becomes negative P. Next set. Right, so in number 5, I assume you still remember reduction with negative angles. If you don't, go on to Simon's Maths grade 11 and you can go look at the lesson there. Refresh your memories. Please subscribe. So there I have sine minus 325. Because it's a negative angle, I take it as all negative angles being in the fourth quadrant. So in the fourth quadrant, sine is negative. So that becomes negative sine 325. Again, to solve, I must introduce 35, because cos 35 equals P. So 360 minus 35 gives me 325. The fourth quadrant, sine is negative, so that becomes negative sine 35. Negative times negative becomes positive. Sine 35, y over r, my y value being square root 1 minus p squared, and r being 1, so anything divided by 1 would stay the same. The last one here, we have tan 215, so I have to reduce it to acute angle less than 90. So 180 plus 35 would give me 215. 180 plus third quadrant tan is positive. So that becomes tan 35. Now assume, remember, tan is y over x. So my y value being square root 1 minus p squared, right? And my x value being p, so there's my final answer. Right, so they have written all that problems in terms of p. So this is your third variation of diagram sums. Please practice. There are many problems in your textbook all over the show. See if you can follow the process and do it. Continue practicing. Success is bound to come.